Hello, my name is Alex, and today I will be showing you a general problem-solving method that I usually use myself. There are three main steps to this problem-solving method. The first being understanding the problem and the system that we are operating within for the duration of the problem. This leads into the second step, which is to translate this implicit understanding of the problem into a step-by-step guide that a machine can use to actually solve this problem itself. And the third step is to actually implement this algorithm that we develop in the second step. Now we will be using Codeforce's 271A problem as an example solution that we are gonna be doing with this method. So we start off by looking at the problem statement naturally to understand the problem. We would ideally want to distill this problem statement into a single sentence that is concise in giving us the main purpose of what we are doing for this problem. So I've taken the liberty to actually go through the text and do this shortening myself in order to save some time, and the sentence that I've got goes as such: find the smallest integer that is strictly larger than input and has distinct digits. Now this is a lot to unpack, and it's actually two separate problems in one, as we will see later. But now let's go ahead and try to understand the system that we are working within. So we know that the integer that they're giving us and the integer that we need to answer with are all years. Now we know that a year would be a positive integer as well as a real number. So we are working within real positive integers as a system for our problem. Now, I would assume that most of us understand the system, but for more complex problems, we would ideally go over the system if we are unsure about our knowledge about it. Now, let's go ahead and go to the second step, which is the translation. Let's start asking questions and perhaps even use one of the test cases that they give us to try and reason out how a machine would go about solving this problem. Now, in this specific problem, we don't need to use the test case. We can get through it using just the questions that we might ask ourselves and breaking down this problem into smaller pieces. But if you might be troubled about some of the qualities of how we would go about solving this problem, it would be actually beneficial for you to take the test that they give you and try to solve it yourself first, and try to see if a pattern emerges within your solution to later base your algorithm on that. But now let's go ahead and ask the specific questions we would want to ask. So we know that in our sentence that we distilled, from there we can know that we want the smallest integer that is strictly larger than input. Let's say that input is x. Now what would be the smallest number that is strictly larger than x and is also an integer? Well, it would be simple. What is larger than 1 and the smallest number that is larger than 1? 2. X plus 1. So now that we reasoned that out, we ask ourselves, yes, that is the smallest larger integer than x, but does it have distinct digits? Well, let's assume that it does not, because if it would, that would naturally be the answer, but if it does not, we would find the next smallest integer that is larger than x. Well, that would be x plus 2. If x plus 2 doesn't have distinct digits, then we would go ahead and get x plus 3, then x plus 4, and x plus 5, and this can actually be directly transformed into a flowchart that gives us the algorithm for solving our problem, which we see right here. Now that we look at the smaller, at the loop part of it, of course we notice it is a loop after go through this flowchart, and we think what type of a loop it is. Well, we are actually unsure on how many iterations of the loop we need. So, because of that, this is naturally a while loop. Now, when we are working with while loops, we have to usually consider the probability that it's gonna give us an infinite loop, and we should consider the cases that would actually do that, and we should prevent that. But in this specific case, the problem states that that will not happen and that each of the questions has an answer. But you should actually consider all the possible failures of your system before you start implementing it, so that you do not run into problems later on that will require refactoring of 20 or 30 or hundreds of lines of code just because you didn't consider beforehand. Now we can actually go to the implementation stage, which we actually reasoned out, and we get this code. Now I have skipped the implementation stage of this problem. Frankly, it is because most of the problems will have different implementation stages, and it is not going to be useful if we just go through the implementation of this current iteration of the program. And if anyone would like it, I could make a video dedicated to the specifics of some implementations if there is some trouble in that area for someone. Well, thank you for listening, and I hope you will find this method useful.